Okay, 2 o'clock. Good afternoon and welcome to our second webinar on activity-based modeling and transport. I'm Klaus Nökel from the European Association for Activity-Based Modeling, or EAABM for short. And with me on the call are Tom Friedrich and Alex Erath, one of the two directors. Peter Jones, the other director, intended to join as well, but is unfortunately unavailable today and apologizes for that. Our mission at EAABM is to foster activity-based modeling in Europe. And in this webinar series, we take a look at existing real-world activity-based models across Europe, but not only what they do or why they were chosen, also how they were built. And with this inside view, we hope to demonstrate that today ABMs can be built within reasonable time and effort and no longer are a risky adventure. The two models that we're looking at today come from Sweden and from Germany. It is my great pleasure to welcome the Swedish Transport Administration and Berliner Verkehrsbetriebe, the public transport operator in Berlin. As well as the developers behind the software used, and that's Bentley Systems and Senozon. For each of the two models, we will first hear a presentation from the users and from the software developers, and then there will be time for questions and answers. Please put your questions for the Q&A in the chat and mute yourself if you're not presenting. And I also want to say that this session is being recorded. I hope nobody disagrees with that. Without further ado, let's start with the first model, BVG and Senozon. The floor is yours, please.
Thank you, Klaus. I'll take over, and hello, everyone. Just need to switch to our presentation. Hopefully everybody can see that. BVG and Senozon, we will present today the combination of two models, a MATSim model and a VISUM model, and how they cooperate together. BVG uses both models for various purposes. That's the reason why we do the presentation together. In the first part, Helena will give us the introduction why BVG uses both models and what are their targets and their visions. I go into technical details how BVG can use both models in such a way that they don't need to have cumbersome implementation and scripting of a MATSim model without the user interface. And in the third part, Helena will give us an insight how they use the whole system for policy studies. So in this case, I will go to the next slide and give the word to Helena.
Yes, hello, and thank you very much for the invitation today. My name is Helena Götz, and I work for the BVG. The BVG is the Berlin local public transport provider, and just here as a short introduction, what do we do? Yes, we move people around the city, pretty obvious. And here just some KPIs about the BVG. For example, we have now 16,500 or nearly 16,600 employees. So we're really big and the biggest of Germany. Also, our route length is pretty long from Berlin to Lisbon, and 900,000 departures per day, as well as 1.1 billion passengers as of last year. So the role of my team, we're about 12 people, is to improve our service by data-driven decision-making. So we don't want guts feeling in our system. There's still some guts feeling, you always need it a bit, but we really want to be driven by data. And for that, we of course need our transportation models. As seen on the next slide, we work with the MATSim model, as well as with the VISUM model, but I start with the MATSim model here. And exactly what you see wimmling around on this screen, it's our simulation of DRT vehicles. DRT is for demand responsive transport. So these are specific questions we really tackle a lot with the MATSim model. We ask questions, for example, what if we drop a big fleet of demand responsive transport over Berlin? What also if we close that road in the smaller sense? What if we add a line? What if we change the whole system? So for us, the MATSim model is kind of a what if scenario model, which we really use a lot. And as you, of course, I think you're all very deep in the modeling scene. You know that MATSim model is based on the individual level. So we have 3.7 individuals going about. And that is why it's really interesting that we can really see what is the trip combination of people. How do they switch from public transport to other modes of transport, for example, DRT mode and so forth. So this is really what we use this model a lot for. But later on, I will also talk about some other use cases. On the next slide, I want to give a quick overview what we use the VISM model for. So as you also know for sure, is the VISM model is for simulation and evaluation of medium and long-term operational and strategic planning. So it's rather on the statistical units and not on the individual level. On also this model we use, for example, in a very classic sense. For example, if we have a line extension in Berlin, for example, we talk about the U8 extension. We would model that in the VISM model and then see, okay, how much more demand can we expect on that line if we do that extension? Very classic. And of course, also we work a lot together with the city of Berlin, and that's the advantage of the VISM. It's the officially accepted model, so to say. But yeah, and here you also see that we do not only do demand analysis of new lines, but we also look at the existing network and see what we can learn from it. For example, on the left-hand side, you see a comparison between travel time of the car in the upper picture and the public transit in the lower picture. And we see clearly that where the public transit is weaker, of course, in the outskirts of the city. One also has to say there are a lot less people live there, so it's harder to provide efficient public transport. And there again comes the question of DRT again. So it all works, is one system. And in the second picture on the traffic volumes, you see a classic analysis of the traffic volumes on the different lines, as well as on the third picture, the right-hand side. It's the model split change based on the public transit travel time. So here we made a small analysis. I know it's too small to read, but just for you to know the pie charts, they show if in the first pie chart, we really speed up public transport a lot, how much more people, how much more demand would we have on the line? To the last pie chart, blue is always public transport. What happens if we, public transport is even slower than it is today? We have an issue here in Berlin. There's to say we want to be faster than we are. And that's kind of analysis we do also to convince stakeholders in the city to, put emphasis on the speeding up of public transport. On the next slide, you see the vision we have. Oh, sorry, it's animated. So the vision we have is the first outer layer. The vision basically is the combination of both worlds, exactly the topic of the day, right? So we really want to have one model world vision, and that is not to differentiate, is it MATSim, is it VISM? It is from the outside, it's a model, and we call it also the digital twin of Berlin. I know it's a big buzzword a bit, but also it's really the vision we have. So the model onion would be the outer ring is the VISM on the macro level. Then if we click next time, we see the meso and micro level, which would be, of course, MATSim on the individual level. And then if we even go one more down, we see the SUMO. SUMO, as you might know, is really, really down on the level of crossings, on the level of traffic light optimizations. And in this world, we try to offer our different stakeholders also within the organization of the BVG the perfect or the thing they need for their analysis. So, for example, when management comes and they just want to know, I have this crazy idea. I want to build, let's say, a tube ring around the city. Then we can really do that. Not on the SUMO level, of course, we do that on the higher level, on the VISM level. If another idea comes which needs more the individual aspect of it, like DRT, prime example, we might use the MATSim level. And then really if the the people from the Straßenbahn or cable cars or from the bus network come and they really say, hey, we have that real problem on that crossing, we come on the Zoomer level. So this is the dream of the digital twin we have. We are not there yet, that is to say, especially with Sumo, we are really, really in the beginning. But this really, I have to say, was made possible by the really great collaboration we have with Senozon, because that only allowed us to build up this MATSim model and develop the knowledge. Also now in my team, we have very good knowledge on that, and that would have not been possible without the support of Senozon as well. So we're really thankful for that. And yeah, with that, I would give on to Michi, and you will hear from me later on.
Thank you very much. I go on with the technical setup, and what you see here is just an overview how we build up the MATSim model for the BVG about 4 years ago, was it? You see on the left side there is data coming from Senozon itself, especially the demand side, activity-based demand, which is based on our German model, which we updated once per year, and it's based on the MID, Mobilität in Deutschland, and on mobile device data, which we process on a daily basis by the provided by Telefonica. On the other side, there's the BVG Visum model, which provides us with various information about the supply side, of course, net and schedule, but also about their own specific population, which they maintain, and also specific needs, which Helena before already talked about, is about QKZ, which means in German Qualitätskennziffer, which means something like reliability of one specific transport line. So therefore, it's not only the schedule we have to use, so we also have to use the schedule in such a way that it reflects somehow reality and therefore also reflects how people behave within the model based on the reliability topics of specific lines, for example. And the other part is also very important, is about DRT. So the model which we provide has the 4 main modes, car, public transport, bikes and walks, but no DRT. But of course, DRT is also part of the supply side and also is also part of policy studies and the vision how to develop their services in the future. So this one has also taken into account everything together with the calibration methods using SFV data from BVG and counts data from BVG, as well as other third-party data. We calibrated the model about 4 years ago. In small sentence, it's about the QKZ, it's about their own population, it's about the semantical identical interpretation of the public transport supply side in the MATSim model based on the Visum model, which also has to do some interpretation of, for example, where bus stops specifically lie on a specific link of the network. We have to integrate the DRT support side, so I mean service area, vehicle fleet, access points, and so on. And of course, we did some calibration, but that's just a sidetrack. What you see on the upper right corner are these arrows in between, and those arrows are actually the base conversion functionalities, how the two models cooperate with each other, such that the supply side is always provided from the Visum model directly and on the definition side of the BVG, and on the other side, based on the needs of BVG, sometimes we do updates on the demand side to have the right base activity-based demand data set, which can be used within the model. So what's more important is how the BVG uses it. So actually the more or less same arrows you saw before are set up in such a way that the BVG can use the MATSim model with not much effort, meaning you have to log into a specific server and you have to provide them with their specific data sets for the policy studies and set up the parameters which want to be used, and then run one specific comment on a comment prompt, wait some hours until the computation is finished. If you have a huge model with a huge amount of DRT data, then you have to wait several days for it. And afterwards, you can export all the data and analyze it within the technical environment of BVG. We call that setup MODAS, Mobility as a Server. which means we provide this environment such that BVG can use it autonomously to do their policy studies. So the goals are an autonomous usage of the MATSim model to do policy studies, no hardware maintenance, no server maintenance, things like that. Also the deployment we provide for them. So for example, if there's a new update of the MATSim source code or some external extension from ourselves or for third-party data, companies, then we do the deployment on the server for them. They don't have to work with this rather cumbersome and huge and very confusing MATSim config file. They only have to define parameters they need to define, and everything else is provided for them. If they want to do any kind of infrastructure changes, they don't need to manipulate XML files or things like that. They can actually all model that within the vSUM environment and just export it and import it into the MATSim model. And all the policy analysis can be done by BVG completely independent of the MATSim model, using Power BI, using vSUM, or the tool of their wishes. As I said, the input data sets, which they can always change without interference from our side, is the network and the schedule, the reliability information of the schedule. They can define the study area, and for DRT, the service area, the DRT access point, the fleet sizes, and the vehicle types, meaning how much person can be transported maximum per vehicle. And also the parameters. The parameter set is quite large. There's just a small example on the right side, but I'll give you a little bit more of overview. The flexibility is quite, let's say, focused on the needs of BVG, but wide enough so they can do a huge amount of policy studies for various purposes. On the study area, they can define the vSUM file, of course, which I said before, the simulation area, which means they can also use the whole model, separate part of the model, such as sub-model, as a smaller one, which doesn't take all of the demand and all of the regions into account, but allows one to calculate the relaxation process much faster, because you're probably only interested in the left side of Berlin rather than the right side. But you don't have to do that. Of course, you can run the whole model if you want to. We implemented the model such that BVG can always define what the population sample is they want to calculate. So from a 100% model, which means 3.7 to 4 million agents and additional single trip agents to that, down to a sample of 10%, 5%, whatever they need. It always to do with precision, but also with computational performance. The number of iterations until relaxation is reached can be defined. The population itself can be defined, can be replaced by an older one or by a newer one. At the moment, there are 2 populations available. Probably soon there will be 3. The car availability scale shape defines how, for each region of the Berlin model, how much car availability is used for the population. So you can downscale it to 0, then nobody can actually use car. So there would be car-free Berlin. So you can do this kind of policy studies if you want to. On the behavioral side, they can redefine the beta parameters for the behavioral model, detour factors, short time trip distance, offsets, DRT, travel time difference factors, so a various of behavioral beta parameters which can be adapted. On the DRT side, there is even more. As I said before, the service area can be defined somewhere from whole of Berlin to a very small area. It can be defined where the access points are. And also, as a specialty, BVG can restrict which public transport stops actually are used for an intermodal change of DRT. So on one hand, every stop can be used. On the other hand, only a specific part can be used and can also be defined by the BVG. Fleet sizes, seats per vehicle, and so on, of course, and also different price regimes for different purposes. So we can differentiate between direct DRT trips, so only using DRT, or intermodal DRT trips, which is combination with public transit. And to run it, that's just that command down here, which has to be performed, and then a little bit of waiting. And after that, the results are there to analyze. To take care of the time. Just very shortly, the challenges. Some of them are already said. What's a really important part is if we convert supply side for any purposes, we need to do that in a generalized format such that the demand is always reconnected to the adapted supply side. That was one of the challenges. On the DRT is supply side definition, and also things like performance, which we had some experience with projects before, research projects where we increase performance of the DRT, which helps, of course, by the computation. And on the usability side, we do not implement any software and any GUI or something like that, but we help them to use the server in a very simple way. So they can actually define that according to input data sets and parameters, and they just run one command and gather the results. And the idea of those parameter sets, of course, they could be extensible if there's more needed, more influences, which needs to be performed for policy studies. The analysis is on the other side then very simple. The model server is only here to do the computation. It calculates the results, it provides the resulting data sets, and then BVG can use all the produced data sets in their own environment, so apart from the model server, which is also important because it's only a computation machine, so it does not store data, it does not provide any archive or things like that. It's really just for the computation. So the resulting data sets are then back to the BVG environment, and there we provided, of course, all the MATSim XML output data sets, all the pictures which they're produced by standard, as well as 5 different tables, which is a reinterpretation of some of the output data sets which MATSim produces to have an easier use within the BVG environment, for example, for Power BI or also for VSUM and things like that. So we provide 4 persons as a crisp description for the population, trips and stages as table format, such that they are connected to each person of the population, links and stop and route to define the routes and the specific route stream which they use for each trip or each stage of the synthetic population and demand. And as I said, used in Power BI, VSUM, or anything else within the BVG environment. So then we give the data back, or they give it back by themselves because we don't interact here. And therefore, I also give it back to Helena for an example.
Thank you very much. Yeah, here the first example, and I start with the most recent one. I don't know who of you is familiar with Berlin, but as you might have read, we as a city are blessed with a new extension of the A100 motorway. It was extended for 3.2 kilometers, and the weekend it opened, it was, well, not the success story they wanted. It was a huge traffic jam. And here on the left-hand side, you see the simulation of this traffic jam. And if we click once more, yeah, exactly, thank you. We see the Google Maps, and that was really our proof of concept for the so-called digital twin, where we wanted to see, okay, we see this in reality on the left-hand side. Google is here our reality. We see the traffic jam that Google has, and if we simulate the whole situation with our model, we come to the exact same results. We see the 3 control points, and all of them match more or less. And that is really great for us for the development of this so-called digital twin. This is not the only real-life example. Of course, we tested, we had some others, but as I said, this is the most recent one. And yeah, for the future, of course, we want to do that simulation before it actually happens, not after. And that's, of course, easy and not so helpful anymore, because then everybody else knows already there's a traffic jam. So in the future intention is really that we model the things that happen predictably in the city, like building sites or openings of new highways or so forth, in advance so that we know, okay, there is a traffic jam. Okay, what does it mean for our buses? Do we need to reroute our buses in advance? Then we can prepare people, we can better communicate also with our passengers and so forth. That's the most recent example and also the prime example of the collaboration between the MATSim and the Visum model. At the moment, we first do the simulation in MATSim, so we know how many people would cross there, would go there on the individual level, and then we transfer that to Visum because there's the calculation in Visum is then faster. In the future, we still want to further develop that process, that it is really an integrated system. So that's the MATSim Visum example. If we go on the next slide, from now on I talk more really about what we do with the MATSim outputs, because we really have a great database from MATSim data where we see basically all the 3.7 individuals of Berlin. So it's the population of the city and visitors into a Berlin group I know anyways. And we see how they move around town. Here we do different analysis to understand how does Berlin tick, what's the movement in the city, and how does it change. So for example, we look a lot at car kilometers of actually. So 84% of all car kilometers within Berlin take place in the B area. B area means everything outside this center area that is with the big black line. Yeah, I know it's interesting. We're the public transport provider, but we actually look a lot at car data because, of course, these are the guests we miss. We want to get these guests in our system, and so we need to look, where are they? What do we need to offer to them? So this is a very nice map, I think, as you see, and it was done by our modelers. And we had in the end so many requests for such nice maps that we decided, okay, we create a tool where everybody can help themselves with analysis. So if we go on the next slide, we see a screenshot of our Power BI dashboard that we built with the database that came out from the MATSim model. So it's all the individuals going about in Berlin, and we can put in different filters to understand, okay, I just wanted to know everybody who goes to the district of Kreuzberg, for example. So if you see here, exactly, thank you, Michi, the destination is Kreuzberg, and so we put it in the filter, and we see everybody going to Kreuzberg, what's their model shift, what's their main mode of transport, and so forth. And we see a lot of different KPIs. You can set 1,000 different filters. If you look on the left-hand side, there are all the filters, and it's more if you would scroll down on the actual dashboard. And that is really helpful for us as like on the management level here, I'm the boss of the team. So for me, this is really useful because I can help myself with that. And I don't have to ask every time my analysis team, hey, I need this, I need this. It's really very handy to have this interactive tool. And it really already helped a lot in many policy decisions and discussions we have had. So this is one example of the dashboard. If you go on the next slide, we see the second dashboard. It's altogether, it's 3 dashboards, I have to say, but I'm only showing here 2 because these are basically my favorites, the ones I use the most. Also here you see in the start, very similar. We see the KPIs of model split. We see also here the reason for the way, like is the way, do we take it for work, for education, for shopping, and so forth. And also on the left side again, here we can see the filters. Here we put in, we want to start in Tiergarten and we want to end up in Marzahn. So it's pretty much across town, and we want to see the different modes that do this distance and the different agents, really, like the individuals, and how the KPIs sum up. I think it's really also cool. We can put in, for example, the filter on the left-hand side, you see it, PKW-Verfügbarkeit, which means availability of a car. So you could change that here to not available, and probably then the model shift would change in the advantage of public transport, of course. And yeah, this is really useful. And on the last slide, also one of my favorites, it's on the same dashboard further down. You would also see a graphic output of these requests you put in. So here on the left-hand side, it's Tiergarten. The district, or it's an old district in Berlin. It's not a district anymore, but it's a city unit, let's call it, to Marzahn. And we really see here also in Tiergarten, this is where the biggest dot is on the very east. This is the Hauptbahnhof, the central station. Of course, here the most people would leave. And then you see on the right-hand side where the most people in Marzahn, where they would arrive. And what is really a cool aspect here, it's actually a bit hidden, but if you see this last line in the chart, where it's written Gesamt, it's in total, we see the total number of ways, which is 3,780. And we see, okay, the most used mode of transport is actually public transport. It is written then also model split of ÖPNV, exactly where Michi has his mouse. It's 63% is public transport. But what is really cool, we would also see, okay, we know it's done by public transport the most, but we see on the first, on one hand, we see the actual travel time with all the modes. And we see the theoretical travel mode with each mode. So if we go to the 77 minutes, let's just start here. 77, exactly, thank you. Here it's the time which is theoretically done with the bicycle. So if you would not take what you actually take, which is maybe public transport, if you would bike, you would take an average 77 minutes. Then we have, of course, in the next one, we see the actual ways done by bike. It's 88 minutes. So, okay, you are actually a bit slower, but it's really cool. And then we go on. Here we have the car, the same thing. We have the theoretical travel time by car and the actual travel time by car. It matches, it's 45 minutes. And then we have the same thing here, theoretical travel time by public and actual. So what we really like about it, and we can do that also again with all the filters, is we see from destinations, okay, usually this is done by public transport. But if you would do that by car, how much longer or how much shorter would it take? And with that, it's really good for us to identify routes, for example, where public transport is really lacking behind. So, for example, there is many, as we've seen in the map in the very beginning, there might be some routes where public transport is really a lot slower than the car. And this helps us to identify these routes. And then, of course, propose new lines or improvements, at least, from what we can do. Yeah, that's also where I want to finish. The dashboards that were really handy tool for us, which comes from the, basically, we call it Wegetabelle, or like a big table of MATSim output that we put in this nice dashboard that is really helpful for management and also helpful for the team because they have less work with analysis. Yeah, thank you very much. That was it from my side.
Great. Thanks for the perfect timekeeping. And Michi, we have ample time for questions and answers. And okay, here is very first question. I was just wanted to motivate you to write your questions into the chat. Alex is asking that in 2019, I learned that BVG is required to use the Visum model in cases where opponents of policy measures might want to have a policy decision reassessed by a court. Ah, okay. Is that true? And has it changed, especially in light of experience gained with MATSim?
So I'm not sure if I understand the question correctly, but I answer and you tell me then if I answered it correctly.
Okay.
But yeah, if we have discussions with the city, it's often more accepted if we come with the Visum model because the Visum model is the big accepted one. And especially for like official NKUs, Nutzen-Kostenrechnung, sorry, I don't know the English term for that, but the official calculation whether a new line is worth it financially. Those calculations are done with the official Visum model. But nevertheless, for like informal or discussions with the city, it is still very useful to have this depth of data that we get through MATSim data. So I would say, yeah, in the really official frame, and I think also Michi had that on his challenges slide, it is the Visum as the established model, but the MATSim data we derive is really like, it's just so much more fruitful in discussions if you can go in further deep. Because the Visum model would, for example, never answer you the question on this specific traffic light. What does it do? And with the MATSim model, and especially then further on, if we combine it all the more with Sumo, we can really give more answer here that is not possible with Visum, I think.
Okay, Alex has a follow-up question apparently. Unmute yourself.
So thanks very much for clarifying this, so it's still the same situation, although you gained experience now. How often do you compare the output of the two models? Because everything that BVG can produce is an output you can reproduce. The other way around, that's not the case. So is that a question that you actually want to answer and challenge over the long time, so that over the long time you could phase out the BVG model, or are you comfortable with running two models and maybe have contradicting results?
So I don't think there's any agenda of stopping one of the models, or especially not the BVG model, also not MATSim. It is, we compare the results, yes, and yeah, we can live with it, and we just work on the models that they really integrate each other better. So that is our current process. I think I'm in the team here since 2.5 years, and since I arrived, it was the dream of our main modeler to have, you know, one model, he called it cycle. And I think now we're really at the point where we can say we really actively work on that. And with that one model cycle, also this issue will be integrated and looked at further and further. I think when I came, we only compared the results like every now and then, but now we do that regularly. If we have a big simulation going, and especially oftentimes is, you know how it is, bosses are not so happy with the result, and now they know we have two models, so we have one result maybe with BVG, they don't like it, then they say, hey, do it again with MATSim, maybe it's better then. And mostly it doesn't change so much, so mostly they're same, not so happy or happy, whatever. So we have actually good experience there, and it's not one of the main challenges, I would say. I think we can live with that.
Yeah, and
thank you.
Sorry, Alex.
So the recommendation from you to other authorities who need to run models would be organize the money and have two models up and running all the time. Or what would you recommend if money was an issue? It would become an issue at some point.
Yeah, that's the thing. I think like we're a big place here. And we have the luxury of having my team and having two models and having the experts here that work for us that can run these models. I don't think that for a small city it is feasible and maybe necessary to do all the thing we do here as the big city of Berlin, but that's exactly where Senozon might come in, because they can also support there with the help of MATSim, and maybe Michi can talk more about this, but we also challenge Senozon every now and then, because we are so deep into our business and we know models so well, or my team knows them so well, that we challenge them or work together on to develop something. But I think Senozon has a lot of products that help especially smaller communities, or where there's not so much money, where you can actually use it more as a service rather than doing everything yourself.
Yeah, just to extend here, yeah, that's actually also one of the reasons why we maintain a German model. So there's at least a hot start if you want to build up a model for a specific region, and sometimes the specialities are not that extensive like in the Berlin scenario, and then you can actually produce quite feasible fast a model or at least feasible policy studies without any huge effort and any large budget.
Thank you. We have a second question that I would like to turn to Udo. Can you ask?
It's not really a question, it's a comment. I'm a little bit surprised about the discussion about MATSim against BVG and so on. I think I'm a modeler. I work since 1991 in modeling, and quality of model is, of course, partly dependent on the software, but at all it's a question of calibration, validation, and setting up a good model. It's not so important on which software. Software, of course, can help a lot. If it's a good software, it will make the quality of will make the work for good quality model easier. Of course, you know, it will support the modeler. But at the end, it's a question of the model quality. It's the calibration and validation and the input data. Don't forget the input data. Yeah.
So I completely agree
there.
Yeah.
As long as I don't see another question in the chat, maybe I can ask almost a follow-up question to Udo's comment. We've seen the data that go into your hybrid model, and some part of it comes from MATSim and some part from the VISUM model. And when I see something like this, I immediately ask myself, is it a problem to ensure consistency between those two sources of information? Somehow you have to fuse those two sources into one model. Was this a challenge when you built the model to I guess it has to do with the interpretation of the VISUM model information when you turn it into MATSim, for example, something like this. But you also mentioned connecting demand to supply, especially, I mean, we're not talking only about building the baseline model, the reference scenario, so to speak. It also happens when you start constructing scenarios, some build scenario, and let's say you change the public transport network, or you change the population due to a housing development somewhere, and then you want to serve that new population. How do you do this in a way that works only for the from the point of view of consistency of the model? I mean,
yeah, there are actually two parts of it. One side is the demand versus the population. I think that's a speciality which we've done together with the BVG. So to have their population, it's kind of a tricky situation if you have demand and then you need to replace it with another population. But at the end, since our model is also a population-based, activity-based model, so you have two populations and you can actually exchange the demand rather easily, because you can handle one of them, something like a 100% survey of the other. And therefore you can actually exchange that. It's not that tricky as it seems in the details. It's always tricky in the details, but in principle, because it's a population-based demand, it makes it much easier if you, rather than if you have zone-based demand, which you have then rezone, which can be quite horrible. So that's on the demand side. On the supply side, since the demand is, technically speaking, microscopic, so coordinate-based, the connection between demand and infrastructure, it's not that tricky. The speciality comes in this case, and that was the first time we saw that actually by BVG, that they modeled the infrastructure with the bus stops, with the stops at the links and not at the nodes. I was before, many years ago, was familiar that nodes are the connection points where you have the bus stops in the VISUM model, and there's two ways to model that. And in MATSim, it's always like that. There's a bus stop is always at the end of a link at the pseudo network. So therefore, you have to rearrange your link network for the pseudo public transport such that the bus stops are also at the right place in the MATSim model. And that's the tricky part. If you have that, then the connection between demand and supply side is rather easy. As long as everything is coordinate based, then it's not that tricky, but you have to be sure that it's always completely connected. Otherwise, if you have, for example, disconnected graphs, then you have a population which cannot go from A to B, and then everything crashes.
Yeah. That's what I imagined. We have one question that does not strictly refer to the Berlin model, but I would like to paraphrase it. Thomas Schatzmann from ARE asks, basically, Michi, do you have a Swiss model as well? If yes, do you rely on Swiss cell phone data? But I guess probably my backstage guess about the MATSim data that went into the Berlin model is there is mobile phone data behind that too. So you can answer in general, what role does mobile phone data play in such a model construction?
Our first part is yes, and we have a German model and a Swiss model. Everything is updated once per year, and both are fed with mobile device data. In Germany, Telefonica. In Switzerland, is Sunrise. It's extremely valuable if you use mobile device data in a correct way. And I say that because it happens a lot that it's just let's say, falsely interpreted, that one part will say mobile device data gives you all the information, and the other part would say everything is so rough you can't use it for anything. We use mobile device data explicitly to create activity chains, so activity-based demand. We do not produce frequencies for A to B or something like that, or frequency data on street network or something like that. So we use that as an enrichment of a survey data set like the SFV, like the MED, or like the microcensus in Switzerland. And we use that to update travel demand for a population on a yearly basis. And that helps a lot because things change as much faster than I was used, let's say, 20 years ago. Mobility changes faster, and so it makes sense to update the demand side more often.
Okay, many thanks. Okay, Alex, does your question go beyond what Michi already explained
it
a
goes
little bit?
a bit beyond. So he explained how he is doing it, but in Switzerland, we have plenty of cross-border regions which are important, especially if I myself live in Basel and work in Basel environment. But there is also Ticino and Geneva, and there are other areas in Europe where we have cross-borders. And that problem so far has been that the mobile phone data only covers the movements within as a country, but not across or between countries. So how would you go about if like Basel comes and says, hey, let's build a model for the cross-border region together? What would be your approach?
Yeah. Straightforward answer is I need mobile device data from all countries, from all three in this case. The reason for that is in the mobile device data, you have information about the roaming part. So you get information from the mobile device data. So there's somebody from another country logs into the roaming and then provides signalization data during his movement within the border of interest. There are two problems. First of all, you have absolutely no clue what is the percentage which are covered by that specific mobile provider. So on one day, it's 20% of the roaming population. The next day is 5%. So you don't have that kind of information. So scaling to a complete 100% demand is a tricky business. And on the other side is, especially if you want to have Basel with 3 regions, you also want to have a synthetic population, which you are assigned a specific movement pattern. And with roaming data itself, you only know it appears at the border and then moves around in Switzerland and then disappears again, but you have no information what kind of verhaltenshomogene Gruppe you have.
Okay, Alex, do you need to add? Otherwise, I would like to wrap it up here and switch to the second model.
Just a short point. I was surprised that Michi was saying he needs mobile phone or would use mobile phone data from all 3 countries. Wouldn't it be a possibility to say, okay, the main traffic is within one country, and then use like another approach for the other stream, like the household travel diary survey? Would that be more pragmatic? But apparently not.
Well, it would be more pragmatic, but if you want to use mobile device data to generate cross-border traffic, then that's the answer.
Okay, this way on.
Yeah. Fair enough. Okay, thanks again also to the lively discussion now. Thanks to Helena and thanks to Michael for their co-presentation. And we now switch to the second model that we want to look at today, which is the model used by Trafikverket, the Swedish Transport Administration. Olivier is here to introduce us to that model, and this model was used. It was built using software by Bentley Systems, and Gaurav is also on the call to shed more light on the construction of the model. Please go ahead.
Thanks, Klaus, and thanks again for this opportunity to share some of the details. And I have the pleasure to share this presentation with Olivier from Trafikverket, and I'm excited to show some of the details of this new model. Just to share the agenda, as I said, I'm going to split my presentation, or this is our presentation with Olivier. He will start with showing what this model is, and then I'll talk about how this model was constructed in OpenPaths. And I think the focus here is a lot about how we are addressing some of the key challenges that we discussed in EAABM software committee meeting, specifically about how we can move to ABM and what are those barriers which is stopping us from moving to ABM. And we'll take some examples from this SAMPERS model to see how OpenPaths is addressing some of those issues. And we hope to conclude this presentation with some good discussion in the end. So Olivier, it's over to you.
Yes, thank you. Olivier Canella, I'm working for the Swedish Transport Administration. I'm part of the development team of transport model and work on SAMPERS 4 the last years. So SAMPERS 4, its name is a fourth version of SAMPERS. It was released first in the late 90s, so it's 25 years old-ish. And we released the fourth version in April 2024. And this one is no agent-based model, so it's not full ABM model yet, but it's on the way to towards ABM. So we have now synthetic population for the full Sweden and a part of Denmark with Copenhagen, since there is a lot of cross-border trips here between Copenhagen and Malmö. And in this model, we have new car ownership at household level. We have also driver license and public transport card ownership of individual level. We increase number of trip purposes. And now with synthetic population, we can do equity analysis. We know who are the winner and losers at different socioeconomic groups for each analysis. And this model, we did it fully in-house at Trafikverekt, development implementation of the models. It's with some help from Bentley, but mainly in-house without consults. And like with, I say, it's towards ABM. So we have some step that we want to continue to add in this model. So maybe the next one will be time departure choice model or remote work after pandemic to include that in the model. So we can take the next slide. So yeah, we have different models in the national Swedish traffic model. We have one model for long distance trip. In this one, we have plane, car, bus and train, and then we have 5 regional models with different regions. We have the north part is quite big. You see on the first picture on the left, there's not so many people living there. We have Malmö with Copenhagen. We have Göteborg, we have Stockholm, and one more in the middle. So we have 5 different, so we can choose to run only one, or we can choose to run 2 or 5 or all of them. And it's micro-simulated from trip models with 30 processes. And everything is done in OpenPaths M and Agent software. And above OpenPaths, we develop our own user interface since it's quite complex model with 5 versions. Everything is inside one project, one calculation flow. So we have interface for user to make easier choice. And we also added some webhook to get some status in Microsoft Teams when the run is finished or if it's failed or something. So you can take some days to run if we run all the part of the model, both 2 scenarios to compare them. So it can be useful to get an email and not check if everything is going well all the time. Can take the next one, how we use the model. The main application is to compare different projects between each other, make economical appraisal of those large infrastructure, both rail and roadway. Then we have other tools at Trafikverket to analyze smaller rail and road projects, also some freight model and port analysis for boat. So SAMPERS is one of the model suites that we can use. And since the last release, 2024, we analyzed 25 different projects with this model. On the picture here, you have some example. Not all of them is SAMPERS, but that's only railway project in this map. But we are publishing each 4 years proposition for the government on which infrastructure we propose to invest in the next 10 years. So we just released that 2 weeks ago. So it was a big happening for us. But it can be used also for policy analysis. We have congestion charges, Stockholm, Göteborg, so we can analyze if we want to change the level, if we want to change the design, add more congestion charge. And then we use it also to some input to other models. We have using OpenPath Dynamic in Stockholm and Göteborg also for mesoscopic analysis. And then a lot of people are asking on day flow for forecast to make acoustic analysis. So it's different type of product analysis that we do, based mainly to economical preserve the main one. And now I leave to Gaurav to continue present.
Thanks, Olivier. So as you said already, this new model was implemented in OpenPath. And for those of you who don't know what OpenPath is, I think a lot of you already have some familiarity with OpenPath. So Trafikverket has been using ME or M for a very long time. As we learned today, the SAMPERS was created in 1990s, and for last 25 years, they have been using M. But recently, or a few years back, we released OpenPath, which is a harmonized product, which includes OpenPath M and OpenPath Q, which are the network modeling software. It has OpenPath Dynamic, which is DTA software, and OpenPath CTF5, which is for visualization, and OpenPath Agent, which is for demand modeling. So in SAMPERS 4, they are using OpenPath Agent for demand modeling, and they are using OpenPath M for the network models. And both M and Agent, they have UI and API. And so as we heard from Olivier, there are a lot of calculation that happens, and they did write their own custom scripts as well. And the APIs in M and Agent, they allow them to create their own workflows in SAMPERS 4. So let's start with some of the challenges that we talk about in moving to ABMs. And one of the first things that we been hearing is, what if I don't want to switch to ABM, but rather I would transition to ABMs? And what it means is you have, let's say, an aggregate model. And so we can think of these demand models structure as some sort of spectrum, right? So if you look at on the extreme left side, we have zonal aggregate trip-based model. And then on the extreme right side, we can think of as an ABM. And the idea here is that, can I transition to ABM by making some incremental changes? So OpenPath Agent as a platform, it provides tools. It's not, it doesn't dictate a demand model structure. It has tools with which we can create various kinds of travel models. And Trafikverket made this decision to move to a hybrid disaggregate tool-based round-trip model, which we heard from Olivier. And in order to create such a disaggregate hybrid model, we can think of where would it be placed in between trip-based to activity-based models. So the SAMPERS model is actually can be seen as some sort of hybrid model, which is not fully tool-based, but it can be easily upgraded to tool-based or activity-based model when Trafikverket is ready to make those changes. But the idea here is we can make incremental changes and transition at our own pace in adopting a complete ABM. And you can see the iconography on the left side. You can see what kind of agents being used in various kind of models. So in this example, on the left side, we have a trip-based model from Houston, and on the extreme right side, we have an activity-based model from Perth. They are all created with the same set of tools, and we talk about the SAMPERS 4 model a lot today. So since it's a disaggregate model, the first step is to create a synthetic population, right? And this is one of the challenges that was discussed in the committee meeting as well. And OpenPath agent has a population synthesizer, which is built in and which is part of the software, which can handle both the household and person level controls in creating a synthetic population. In this process, we can specify target at different geography level as well. And there are specific features which I think a lot more relevant for the application outside the US, where we don't have enough, let's say, household survey to create a synthetic population, and there are specific software feature which can help you take advantage of a small sample in synthesizing a good population. In terms of the methodology, the unique feature of this synthesizer is that it does a simultaneous balancing across all geography units and all geography levels. So there is no hierarchical treatment of geographies. And what does it mean in simple terms? There is no error accumulation to the extreme last geography or the extreme last geography unit. And since it's part of OpenPath agent, this is and we don't need to rely on third-party tool in creating a synthetic population for this hybrid model. So for SAMPERS, as we heard today, they synthesize for this model. The population was synthesized for the entire country and some part of Copenhagen, right? And so for the base year, about 30 million people were synthesized at about 11,000 TEZs or zones. And in order to do that, pretty detailed set of controls were used at the population level. There was total population for each zone. There was a joint distribution of the population by age and worker, joint distribution of age and gender, joint distribution of household type and household composition, and the population by income category as well. And you can see some of the statistics on the right side. And this population, we can run it. It was run from one of the runs. It takes about an hour on this. It's not that big of a machine, but we were quite pleased to see that with such a detailed controls, it can be done within just an hour here. Let's see some of the details of this synthesizer further. So when we talk about a synthetic population and how we evaluate a synthetic population, I think sometimes we focus a lot more on how well we are, matching the targets. And I think we would like to take an opportunity here to share that matching controls is not the only criteria we should be using in evaluating how good a synthetic population is. We also need to look at how unbiased the expansion process is when we are trying to take a sample of households and creating a synthetic population. So, in agent, we look at both the uniformity in expansion, so which means that how well the expansion factors are being distributed, and the expansion factor can be defined as the total weights of the synthetic population and divided by the initial weight of the household sample. And so we want the expansion factor to be as close to 1 as possible for an unbiased, fully unbiased expansion, but we have to have some expansion factor distribution, because otherwise you won't be able to meet the target. So here for SAMPERS, you can see on the top we have the uniformity distribution, which shows that indeed the expansion factor distribution is kind of centered around 0.5 to 1.5, which is good to see. We want the peak to be around 1. And in this case, the total population was matched exactly for each zone. And since there were so many joint distribution targets, we do see some of the controls which had slightly higher relative error, and it's because there were small numbers, and when we take the ratio, the percentage may look high. But overall, we were quite pleased to see that the match was good, and also the uniformity was not destroyed. So after we have the population synthesizer or a synthetic population, we need to make a decision on what we want in the model. And that was done by Trafikverket, where since it's a disaggregate tool-based round-trip model, you need to have those individual agents on which you can run the calculation. So in OpenPath agent, before we jump onto the choice models, we need to define or select what we want from this travel model. So here, we call it as an agent schema, where there are many different individual agents available. So here, since it's a tour-based kind of model, we can see we have tours and trips being selected as an agent. And you can see there are other agents which are not selected here, which are cars, fully joined tours, subtours. So these are the agents which are reserved for activity-based models. So when Trafikverket is ready to upgrade to activity-based model, they don't need to start from scratch. They can simply add these agents in the schema, and then they can build upon the schema and add more details to move towards activity-based model. So after we define the schema, we need to add details of different choices, right? So any travel model has a sequence of choices or sequence of steps. Those steps can be choice model, or those could be some sort of intermediate table processing. And if you have activity-based model, then you can have things beyond choice model as well. So in this SAMPERS 4 model, there were a series of choice models, a series of logsum calculations, and OpenPath agent provides an interface in which we can configure all these steps. So here you are seeing the mode choice model for individual discretionary tours, and you can see what the coefficients are. You can see exactly the expressions. You can see what the alternatives are. And so it provides an intuitive and transparent interface to understand the model, and there is a live validation of the model. So when you are typing these expressions, you will see that if there is an error in the syntax, it will be caught right away. So you don't need to wait for hours to find out if there was a typo in some of the choice model. So through this interface, we believe that everyone and anyone on the team can really understand the model and see what's going on in the choice models or in a demand model. So once you have all these choices done, then we need to run the model, right? And in this case, we talk about sampling sometimes, and the sampling of the population is basically sometimes a way to speed up the performance of your travel model. But in this case, in SAMPERS 4, as we know, this is a model for 5 regions, and it's a single demand model which can be run for 5 different regions. The way population sampling is done is actually quite interesting, where they use a differential sampling where since every region has its core and it has its own buffer, they want to have very high resolution in terms of the population for the core, and they are okay with compromising the details outside the core region. So in this case, they sample 100% population in the core and 50% as the sampling there for outside the core region. And this can be seen as some sort of interplay between internal and external part of your travel model. So for those of you who don't have multiple regions, you might have some sort of external part of your travel model. And typically those external components are developed outside the core demand model. So this is an interesting way of linking the external and internal part of your travel model, and so they can really interact within the same demand model structure. And you can see for different part of the region, after doing the differential sampling, we see the runtime for each of the region, and it's fairly it's not super powerful machine. It's only 8 cores, 64 gigs RAM, and we were pleased to see that the runtime after moving to a completely disaggregate model is not in hours. It's quite manageable. And again, a note on these calculations is that they do quite heavily segmented logsum calculations, which actually represents the significant part of the runtime. And there are some options to freeze them in case you don't need to run in scenarios. But those are simply some technique on how we can make this model even faster. But there are some options here already with which we can do sampling, and moreover, we can do some sort of a differential sampling to create some sort of core versus the buffer part of the region. Another challenge which was discussed in EAABM committee meetings was the calibration, and irrespective of the travel model structure, calibration has been one of if not the most trickiest, but it's something that takes some time, right? And it's a lot more tricky for an activity-based model as well. OpenPath agent has automatic calibration feature with which we can calibrate travel models. And this is a tool for modelers. And one thing we would like to emphasize here is that Trafikverekt designed the model, they configured the model in-house, and they were able to use this automatic calibration feature to calibrate to their own data set. So they define what targets they want to add. So in this case, they had number of trips by different regions, by different trip purposes, by different travel modes. And then they also had some targets for the average trip length for each region again, and for each purpose and mode. So they end up creating around 1,000 calibration target. And you can see some example here. This is a target for the average distance by car, for the work trips in the Skane region. And similarly, we have another target for total number of car trips by work mode, and my work trips, and for again the same region. And the idea is that they are changing both the ASCs and the coefficient on distance, and that was all done by themselves in-house. And we were quite pleased to see that they configured this all together, and they were able to save some time there. The last challenge that we want to talk about here is the micro simulation noise. And since SAMPERS 4 is a disaggregate model, they need a way to manage stochasticity, and OpenPath agent has a few options to convert the probabilities and utilities into a discrete outcome. And actually, it was Leonid from Trafikverekt. Back then, he was at Trafikverket. He actually presented a paper at ETC 2022 where he compared the Monte Carlo simulation and the utility simulation in the context of car ownership model. And we also added a new choice method in OpenPath agent called analytical, which has no stochasticity, but that's something they didn't use in SAMPERS 4 yet. But there are some options beyond the simulation method where we can get rid of stochasticity if we want to. But anyway, let's talk about Monte Carlo versus identity. So from the Leonid's presentations from ETC, they analyzed the impact of car ownership, impact on car ownership if they improve transit. So they kind of isolated the impact only on car ownership choice model, and then they compare the difference between Monte Carlo and a utilities simulation. And in this case, what you're seeing is quite involved, but let's try to understand what's going on here. In this case, we have a matrix of car ownership between the base and scenario. So if I look at the middle column here, we have those households which had only one car in the base. And when we improve transit, we see that a lot of households, they kept their car ownership, but about 0.31%, they actually gave up their car because now the transit is pretty good. But we see a small percentage of households for which actually they gain a car. And that's something we find it very hard to explain, because why would somebody buy a car if you improve transit? And that's something is quite pertinent to Monte Carlo simulation. With the same set of inputs and scenarios, when we analyze the same metrics with simulation, we see for the same one car, now this particular household has only two choices. Either you keep the car or you give up your car because now you can use transit. And that's something we don't see any increase in the number of cars for the household because you improve transit. So we want this matrix to be only upper diagonal, and this is something we can achieve with this simulation method. So we don't recommend the Monte Carlo simulation, and Trafikverekt actually analyzed this into a bit more detail in terms of economic appraisal, and that's where Olivier, you can take over and then explain how you use this method for economic appraisal.
yes, yeah, 1 year after Leonid's presentation at ETC, I did my own presentation where we developed this analysis on random utility. So we gave up on Monte Carlo, but focus on random utility, and wanted to see how we choose seed, how does it impact the results at the end, and if we can rely on, if we choose only one seed, can we rely on it, or do we need to run different seeds? So we run one road project in Stockholm, 6 different seeds, the same for base and alternative scenario, so that's individual make the same behavior in base and alternative, but then between the six different roads, they have different behavior. And we explore that on different level of the model, number of trips, mode choice, destination choice, ownership, and today I would focus on the economical appraisal since we don't have so much time. Short of it's one model that we have in SAMPERS infrastructure architecture. So it's the last step, SAMCalc. So it's connected to SAMPERS. And we look at produce and surplus, where we have public transport revenues and cost, budget effect with the taxes and the road tolls, consumer surplus, the major, the main one, and with travel time and cost, and the last one, external effect with emission, traffic safety. So we are looking for forecast year and then for the full appraisal period that we often run 60 years in Sweden. We can go to the next one. So yeah, here we have some results of economical appraisal for those 6 runs on the pictures on the top right. We have utility on the that we have on 60 years for the different 4 categories: precedent, surplus, budget, effect, consumer surplus, external effect, and the dark blue is the consumer surplus. So how much travel time we win with this project. So that's the main advantage of this road project. So that's the biggest one. And on the bottom graph, we have how the different seats change compared to the median of 6 runs. So if we take the dark blue again in the middle one, we have quite low variation. We're from 99 to 101, so plus minus 1% from the median. And then small, some producing surplus, budget effect, external effects, they are changing a bit more in percentage, but in absolute terms, they are quite small change anyway. So when we look at the total one, it's from the minimum to the maximum of those 6 seeds with 3%, around 3% change. But maybe much lower than all the uncertainty what we have in model investment costs, maybe plus minus 20%, population forecast, economical development, if we'll change behavior in the future, or if we'll make autonomous vehicles that are not taken in consideration. So we have much more uncertainties than 3%. So we think that we can live with that and run only 1 seed for big project. And we run exactly the same experimental on the railway project, and we have the same conclusion. It was quite small effect on the economical appraisal. So we're satisfied with random utility, how it works, and with only 1 seed. I can go to the next one. Yeah, here is some citation from me and my colleagues on what do we think about our models. And yeah, with moving to SAMPERS 4 with agent base, we could do equity analysis. That's what's important thing for us, for giving data to the politics to make choice, make decision on which infrastructure project they want to go on. And my colleague here right on calibration. That saves us a lot of time, and now we are using it each major release when we change something a bit bigger, or which is spacier, so we need to calibrate again. So we use it twice already, one for 2024, and we will have a release to 2026. We use it again. It was quite fast the second time. First time take some time to put everything on place, but the second time went fast. Yeah, as Gaurav says, OpenPath is really transparent. We can see all the parameters in utility function. We don't need programming skills to look at them. Everyone can validate, check, and change if they want. And the last station let's give quite a low cost of maintenance, and we have possibilities now to develop more and go to ABM step by step when we have time and budget to do that. So as summary, now SAMPERS for simulates behavior for 13 million people across 5 regions, and a long distance model also. We're using Agent and MA from OpenPath to do this work. That's something that we developed in-house with an hybrid disaggregate round-trip model structure towards ABM in the future. We have some plans to add some steps in the demand model. Automated model calibration saves us a lot of time, especially in the future. Maybe not the first time, but then each time I want to use it, actually the same, so we can reuse a lot. And as I explained, the random utility seeds we are satisfied to use it out to deal, and also results are changed between seeds, and it's not so much. So it's enough with one seed, so exactly 15-20. So we'll stop here and open to question.
Perfect. Many thanks, Olivier and Gaurav. Do we have any questions in the audience? I don't see anything in the chat, but if you have something on your mind, just raise your hand and you can ask. Otherwise, I have one question. We talked about that it's a hybrid model, and Gaurav explained basically that you can achieve any mix in such a hybrid model by scripting against the APIs of both M if you want aggregate, and agent if you want disaggregate, basically. Is that, did I understand that correctly? No?
Carl, very good question. So that's where we have to explain the naming of OpenPath agent. So agent, it's actually being used for aggregate model as well. So you can do aggregate in a 4-step model, trip-based model, aggregate models, which require basically some metric calculation or metric balancing, right? Those you can configure in agent interface as well. So the name agent is a bit confusing, but we are looking for ways to change that. But yeah, it can do aggregate model as well. So you can start with a 4-step model, aggregate 4-step model in agent, and you can incrementally upgrade to hybrid to ABM as whatever you would like to.
The examples that you showed, also including the synthesis of the population, looked like they were disaggregate choices. Actually, is SAMPERS for hybrid in the sense that demand side is fully disaggregate and supply assignment is the aggregate part, or are there parts of the demand that are aggregate and parts that are disaggregate? And if so, which is which?
Maybe I can add, and Olivier, please feel free to jump in. So yeah, the assignments are still static aggregate assignments. It's not, but they do use dynamic for mesoscopic simulation for DTA. But why do we call it hybrid? We call it hybrid because it doesn't have a trip chaining behavior yet. So it's a round trip model, which is simulating individual tours for different purposes and mode. And since it's an individual agent-based model. We call it hybrid. So it's not quite tour-based, it's not quite aggregate, it's not quite ABM. So it's somewhere in middle in the spectrum, and that's why we have the hybrid category. So hybrid is it's a pretty broad category, but there are so many varieties of these hybrid models around.
Yeah, sure. That's why I asked. Okay, yeah, good. Thanks for the clarification. Anybody else before I go on? I have more, but okay, Udo.
I only have one question regarding the calibration and validation. Do you follow any guidelines regarding validation, at least so the map tag or any other guidelines that you showed that the model is consistent with a lot of different statistics from real measured world, I would say?
Again, very good question, and I'll maybe try to answer this question in a generic way, but Oliver, you can also add some details how you use the calibration. So when the calibration procedure in agent, it's when you configure the calibration, you can specify the upper and lower bound of whatever you are changing in your travel model. So if you want to incorporate web guidelines where you have certain variations in, let's say, travel time, coefficient on travel time, coefficient on cost, you can specify that as a range for the calibration process. So so it can take into account some of the constraints which we do want to impose in calibration procedure. So it can incorporate that. At this point, this is agnostic to the model structure. So you can use it for any kind of travel model. And I'm sure, Olivier, you might have some sort of upper and lower bound when you configure this calibration procedure.
Yeah, we have upper and lower bound. And when we look at household survey to take all the calibration targets, but then we compare to traffic counts and passenger statistics for public transport and change some targets to fit better BOS data. So it's not only relying on household survey, but look at difference.
Okay, good. Thanks.
Maybe one more on the simulation noise. You showed the example of consumer surplus that you computed in each of the, or with each of the 6 seats and compared the variation. That is in a way the safest thing that you can do. You compute one result number from a relatively large region, and there you would automatically assume that errors cancel out somehow and the result is relatively stable. The interesting question is, how far can you zoom in, drill down into the results and still stability of or reasonability of the results? What if you look at more disaggregated results? How far can you go? Have you practical experience in that? It must get worse. The question is just how fast, how soon.
Oliver, if you want to answer, I can also add something here.
Yeah, maybe you are better to answer that.
Klaus, you are absolutely right. Finer we go, there can be more stochasticity, right? I think what at this point what we were comparing the effect of Monte Carlo versus any utility simulation, and what we learned. I will tell you about just from my own perspective. I was enlightened on how bad Monte Carlo was when we were trying to use some very fine, very small sample of policies. And of course, there would be some stochasticity it would increase stochasticity if you have a very small region. But like this uncertainty, as we talked, as Olivier mentioned, there are so many other factors of uncertainty beyond the travel model, right? We talk about telecommuting, we talk about electric vehicles or autonomous vehicles, all those also get factored in. And even the assignments, right? Depending on what algorithm you use, you can have a very different answer. So you're right, there is stochasticity, but we just know how to manage that. We need to understand understand how and why we are using the model, and that's where I think we need to spend some more time and really understand the model itself.
Okay, yeah, thank you. Fair enough. Any more questions? 3, 2, 1, no. Okay, thank you, Olivier. Thank you, Gaurav, for this very good explanation of especially also the challenges and how the software helped solving them. This was extremely illustrating. Thank you. And that brings me to the last part of today's webinar, where I share again. So here we go again. First, I want to remind you that this was the second of 3 webinars, so there's one more to go. And if you want, then save the date already. Very, very likely. I mean, the last confirmation is still missing, but very likely it will be on the 10th of December 2025, again, a Wednesday. A little bit later in the day, because as one of the presenters, we've got ActivitySim, and their user is not strictly speaking European, it's San Diego MPO. So just to fit their time zone, we will do it a little bit later in the day. And the other presenters will be EAABM with the user Urban Echo. And with that, I would like to pass to Alex, who has a couple of more information items about EAABM before we close. From me, that's all. Thank you. Alex, over to you.
Thank you, Klaus. Thank you to all the speakers to prepare and take the time to share the knowledge. And this is what session exactly what EAABM about. The effort to share the modeling knowledge among the modeling community. And to attend today, you don't need to be a member, and also not for the next webinar. But if you want to support EAABM's mission to share modeling knowledge, please become a member. You go to the EAABM website, and then there is a membership section that explains how you can sign up. And like this, you get like more information. You will subscribe automatically to the newsletter, and you just support what EAABM does to pull together this knowledge, which is around in the field of practice, but also real research, and bridge a bit between the different aggregated and disaggregated modeling walls. So go to our website where you find all the information also about the next webinar as soon as everything is confirmed, and consider to become a member. Thank you.
Great, thanks for that message. And I hope to see you all again for webinar 3 on 10th of December. And of course, if you are a member of, then we will have several meetings before that, and I will see you there. Thanks again. Have a nice rest of the day.
Right.
Bye-bye, everybody.
Bye.